Hello, math humans. We're going to do B4 today. We're going to be talking about domain, range, and then applications. So our objectives are that we're going to determine domain and range for a function, and then we're going to do some applications, which is math conversation for word problems. All right, the first definition that we need to have for today is domain. And domain is the set of x values of a relation or function. And when we talk about domain, we talk from left to right because we read left to right. Therefore, when we talk about domain, we read left to right. We report left to right. Range is going to be the set of y values of a relation or function. And range is read from the bottom up. Okay? So domain is read left to right. Range is read from the bottom up. So for example number 1, I'm going to be given a function g of x is equal to, and it's going to be written as a set. Again, my really creative numbers, 3, 4, 5, 6, and then 7 and 8. So the domain is the set of x values. So my x's are 1, 3, 5, and 7. And then my range are the y values, and that's 2, 4, 6, and 8. Okay, so that was pretty easy. Example number 2, we're just going to change the way it looks a little bit. So this time we're going to say I have x, I'm going to have a table, and f of x, and I have 1, 2, 3, 4, 5, 6, 7, and 8. My domain, again, domain is always going to be the x values, is going to be 1, 3, 5, 7, and then my range is going to be 2, 4, 6, and 8. So politely organized in table fashion. For example number 3, let me just get a different piece of paper. We're going to have a graph, and we're going to find the domain and the range from a graph. So let's say I have the equation of a line, and this is a -3, and this is 2. Notice that I labeled the points that are important. So if I want to talk about domain, it's the set of x values that work for the function. Nothing about this function is weird. It's just a cute little line. Nothing is out of the ordinary. So when we talk about domain and range, I can also talk about interval notation. Okay? So before we talk about our domain and range, we need to talk about interval notation, and then we need to talk about inequality notation, because these are the two types of notation. If we're not listing our domain and range in a set, then we need to use either interval notation or inequality notation. So for this particular domain, I'm going to say that the interval notation is a negative infinity to a positive infinity. And let's go back and talk about what this means. This graph goes forever and ever to the left and to the right. So it goes forever and ever to the left and forever and ever to the right. This is called an open bracket, which is the same thing as having an open circle on a number line. So if like my number line had a 3 on it, let's put the -3. Then an open bracket is a curved, means not included. Okay, so an open bracket, which would be this, means not included. A closed bracket, and these if you're using interval notation, would be the square brackets, and that means included. So that means that the value is going to be included, And if you think about it like on a number line, it means that it's a filled in circle. Okay? Alrighty. So in this particular case, this graph continued forever and ever to the left, forever and ever to the right. It is not my job to put a boundary on infinity. We can't put a boundary on infinity, therefore it is open brackets, which means it's not included. For inequality notation, remember that this symbol means less than. This one means less than or equal to. Okay, and then this symbol is going to be greater than, and then greater than or equal to. One of the things that they teach you when you are younger is that the larger number goes on the big side, the small number goes on the little side. Again, the big number goes on the big side, the little number goes on the little side. Okay? All right. Less than would mean not included. Okay? Greater than would mean not included, like on a number line, because the value is not part of the solution. Less than or equal to would be maybe it's got a closed circle at the end and a closed circle at the end. So if we go back to this example, it was negative infinity to positive infinity. So it's all real numbers. So sometimes we would write that as that goofy looking R, and that means all real numbers. So then I can write that as a negative infinity to a positive infinity. If I'm going to do inequality notation, I put the x in the middle, and it's going to be greater than a negative infinity and less than a positive infinity. It can't be greater than or equal to or less than or equal to because I can't equal infinity. That's not my job. And so for this particular function, we would write that the domain is a negative infinity to a positive infinity, or we could write x is greater than a negative infinity and less than positive infinity. It depends on the problem whether they want it in interval notation or inequality notation. Okay? Now remember when we talk about the range is read from the bottom up. Well, the bottom value on this particular function is negative infinity. The top y value on this particular function is positive infinity. And so then when I write it in inequality notation, it's going to be negative infinity. Notice that I'm using y because range is all about y, and less than positive infinity. Okay? All right, that was kind of a long example because we had to go back and talk about our two different types of notation, interval notation and inequality notation. So for the next example, let me move this page because I've already written down one of our other examples. So for example number 4, I want to find domain and range, and then I want to use interval notation and inequality notation. Alrighty, so for this particular graph, here's going to be my graph. At a negative 5, I'm going to have a closed-in value, and then up here, I'm going to have an open circle. That open circle is going to happen when y is 3, and it's going to happen when x is 5. So the thing that's different about this function as our last function continued forever and ever to the left and to the right. This particular function has a very specific beginning spot that's included and a very specific ending spot which is not included. So my domain, which are my x values, are going to go from a negative 5, included, and they're going to stop at a positive 5, not included. And so then this is my interval notation. If I do my inequality notation, it's going to be greater than or equal to a negative 5. It's greater than or equal to because it's a solid circle, meaning that the value is included, and no equal to 5, because this is an open circle, which means there's no equal to. And this is my inequality notation. Okay? All right, and I need to tell you that this is a negative 1. I know it's kind of a crappy graph, but that's okay. We'll get the point across. So then for my range is the y values, and range is read from the bottom up. And just if we write this down so we don't forget, domain is left to right. So my bottom y value is a negative 1. So it's going to be a negative 1. My top y value is a 3, not included because it's an open circle. Okay? And then if I wrote this in, this is the interval, in inequality, here's my x, greater than or equal to a negative 1, and then less than 3. The 3 is not included because the 3 is an open circle. So that's kind of cool. Okay? If we do another of these examples, so example number 5, we're going to have a slightly different function that's going to say, the problem's going to say the same thing. Find the domain and range, and we're going to do interval and inequality. So it's nice to be able to have multiple ways of approaching the same problem, because sometimes books will ask us to do this, sometimes they will ask us to do this, and now we have all our bases covered. So here's going to be the graph of this function. It's going to start at a negative 4. I'm going to have a 2, and then I'm going to have a 3. And this function is going to be included here, and then it's going to come up, and it's going to end up here, and it's going to be included as well. So then my domain, which remember is read left to right, and it is your x values, they're going to start at a negative 4. It's included, which means it's a square bracket. They're going to stop at 2, and it's also included, so it's going to be another square bracket. And again, this is our interval notation. For our inequality, I always start by writing the x first. It's going to be greater than or equal to a negative 4. The 2 is also included, so less than or equal to 2. And this is my inequality notation. Okay? Now I'm going to do the range. The range is the y values, and we go from the bottom up. Okay, so I guess I need to give you more information. So my bottom y value, let's say this is a negative 1. Okay, so if I go from the bottom up, my lowest y value would be a negative 1, and it's included, right? Okay, so I'm going to put an included. And then my highest y value is a 3, and it is also included. And then if I do it in interval notation, y is going to be greater than or equal to a negative 1 and less than or equal to 3. This is my interval notation, and this is my inequality notation. Okay? So domain and range can be more entertaining, but for right now, they're fairly straightforward. We just have to remember domain is x, and domain is read left to right. Range is y. Range is read from the bottom up. And then we can either do interval or inequality notation. Okay? So the next part of the video is going to be about applications. And applications mean word problems, and that means take everything that we've learned so far in this particular set of videos, and then let's apply it to a problem. So I have a local window company who's going to charge 75 cents per window plus a base fee of $100 per visit. Okay, they could wash a maximum of 100 windows per appointment. Okay, so part A says write a function that represents the situation. So we always want to define our variables. So I'm going to let C equal the cost and W equal the number of windows. So when you're choosing your variables, I recommend that you use variables that represent the words in the problem because it's easier to not get confused. Okay? So then I'm writing a function that represents, so we're talking about the cost in terms of how many windows I wash. Well, it's going to be 75, forgot the 7, 75 cents per window plus a base fee of $100. Okay, so in case you can't read that, that says 0.75W. Okay, so that's going to be my function that represents the situation. The next question adds an additional word to domain. It says the practical domain. So if we look at this function, this is just the equation of a line. W has a power of 1, so this is just a line. So that means technically that the whole domain is a negative infinity to a positive infinity. But the practical domain means where would the values make sense? So W is equal to 0 would mean that they haven't done any windows. Negative windows would be kind of weird. And then the most windows that they can do per appointment would be 100. So I would say that my practical domain would be from 0 to 100. Okay? This is the real domain. This is the practical domain. So they're a little bit different. This one is only talking about the function. This one is talking about kind of the real world situation. The next part says use the table feature of your graph to complete the table. So again, I'm going to use my grapher. So I'm going to go to my y equals, and I'm going to put in the equation that I've written, 0.75. I'm going to do x plus 100. I could put a w in there, but that takes a lot of effort. So instead, I'm just going to use an x. Okay. I do have that w is the number of windows, so in this equation, x would also be the number of windows. And then I am going to go to my table, and I'm going to tell it to ask for the independent variable. So then I can just fill in the specific data that I want. If I go to second table, and I put in x is 0, it tells me that y is 100, okay, which makes sense because it costs $100 just for them to come out to the house. My next x value is 25, so that means my y value is 118.75. My next x is 50, and I get 137.5. My next x value is 75, 156.25, and my next x is 100, 175. So now let's talk about the units that we would write. For W, that's the number of windows. And C of W, the units would be cost, because C represents how much it would cost. So if they wanted to come out and wash 100 windows, it would cost us $175. Okay? The next part, or the last part of this example, says find the value of W when C of W is equal to 200. So they're telling us the Y value, and they want us to find the X value. So I'm going to use my equation. C of W is 0.75W plus 100, and I'm going to set it equal to the 200 that they gave us. Now I'm going to subtract 100 from both sides, so I get 0.75W is 200 minus 100, which is 100. Now to be able to solve for W, I'm going to divide both sides of the equation by 0.75. And when I do that, I get W is equal to, let me check my handy dandy numbers. So 100 divided by 0.75 is 133.33, because I don't need two equal signs, okay? So this is the number of windows. So I'm going to write my units, which is windows, okay? I can't have 0.33 of a window because that's a little bit weird. So I'm going to choose to round up or down. In this case, I'm just going to round down. So I'm going to say W is equal to 133 windows. So we always want to check our answers to make sure that they make sense. And if I have something that it doesn't make sense to have a decimal of, then I am going to round it either up or down. Technically, either would be correct, but in this case, I would choose to round down just to be safe for the company. Alrighty, that is it for today. I will see you soon.